themselves. I'm Shaleo.
Oh, I'm Andrew.
I'm Abhi.
I'm Dominique.
So us three will be primarily teaching this course, so if you have any questions, who doesn't have Facebook yet?
So just shoot us an email, or if you want, you can come to us individually, cell phone number.
Okay, so jumping straight into action. Does anyone have any? If someone walked up to you and asked you, what is computing? Can I get an answer? Does anyone? What's up?
Using logic to get a result.
Using logic to get a result. Are there any other answers? No? Yeah?
Making these things so computers do stuff for you.
Do stuff for you? Yeah. Basically, a computer in today's world is just something to make our lives easier, right? There's many different ways we use computers, no matter what major you guys go into. You guys will be using computers to get data or finish tasks faster. If you want to make your own startup company or something, it's always really good to have computer science knowledge. So one of the reasons we started this club is because not everyone has the opportunity to take the actual class itself, but we feel like the coursework is something that is essential for you guys going to college with. So we're going to start off with how a computer works. Does anyone have any guesses as to how a computer? Yeah.
Base 2.
Base 2. What does that mean?
Binary.
What does that mean?
Force and 2.
What is that?
Ones and zeros.
Ones and zeros. There we go. Good job. So if you give a computer a string of zeros and ones, basically the computer itself takes those zeros and ones, executes that code, right? So what's the difference in the layer between the code that, I'm sure you guys have all seen code at some point, no matter how vague it is. So let's say this is me, and I'm writing my code. Somewhere in between what I write here, like what I input into like my computer or whatever, something happens, and then I get out a series of zeros and ones, and then the computer can then read that code and execute whatever it wants to do. Does that make sense? No questions so far?
So basically, you don't write in zeros and ones. I'm pretty sure you know that. But the computer only understands zeros and ones. So
No.
what happens in the middle?
Now, does anyone have any guesses as to why we don't write in zeros and ones?
Because it's just really, really confusing.
Really confusing? Definitely, yeah. Yeah, you too?
Because like one letter has like billion digits in it.
Okay. Yeah?
Because there's already a preset program of like commands that you can already use. It's called
Okay, commands you can already use. Yeah?
You need a inverse to show one letter.
Okay, that's a bit advanced. Yeah?
the zeros and ones that each computer understands is different for like different computers.
Yes,
like Macs and
exactly. So all these reasons are really good, but think about if I'm a programmer and I want to share my code with him. If we're trying to collaborate on the same project, and for some crazy reason we're writing in zeros and ones, it's going to be different based on the different architecture within computers, right? So different languages have different ways of dealing with this, and the step in which that gets dealt with is this right here, the
Question mark.
question mark. Yeah.
Elusive question.
Yeah. So who knows which language we're going to be teaching you guys today? Yeah. Java? We are? Okay. So, as I said, different languages have different ways of dealing with this, but Java in particular, and this is just a really high-level overview, but what Java does is, Java has something called the JVM, which is the Java Virtual Machine. So between that code that I had before, the code that I write as a person, it converts. Java takes that code and compiles it and then turns it into code that it passes into this box. This box is a JVM. This box takes that code and converts it into the zeros and ones for every specific computer architecture out there. So each computer has its own architecture, but every different operating system on top of that architecture convert to the architecture of that thing. So for example, if I have a MacBook Pro, whatever operating system you're running on there, we'll take the code that you write on it, and then it knows how to convert that into the processors that computers use. Intel is one of them, right? It knows how to convert the instructions you give to the OS into the zeros and ones that the actual processor sees. So what the JVM does is, are there any questions by the way? Yeah.
JVM stand for?
Java Virtual Machine.
I kind of did read that.
So from the JVM, so how Java deals with the problem of different computers having different architectures is Java just releases several different versions of Java. So they could have one version of Java for Windows, they could have another one for Linux, and another one for Mac. So they take care of all of this stuff with the JVM. So the end result of this is that whatever gets passed into the JVM, and whatever comes out, the user never sees that, because the user writes in the same code, language, on the highest level. But the inner workings, how that code is translated into the specific computer that it's running on, that's all taken care of by the version of Java that you have installed. Does that make sense?
Any confusions about that? So everyone writes in the same kind of Java, irrespective of what computer you're using.
Yeah. So the great benefit of this is, let's say Simmer is using a Windows computer, Harshita is using Linux, and I'm using Mac, and we're all working on the same project. So now I can write my code, I can send it to them, and then it's going to be the exact same. They can run it on their machine the exact same way. Yeah, what's up?
Does the JVM make the program slower in any way?
That used to be the case, but there's lots of optimizations made. So everyone says that Java is a really slow language, but it's really picked up the pace. It's on par with a lot of the
Yeah, it's improved the last few years.
Back in 2005, they thought Java was crap, and it's since gotten a lot better than crap. So.
Yeah.
Okay. Any questions? We're good? All right.
Okay, yeah, so before we go on to the next topic, you want to talk about Okay, so now we're going to talk about the format of the class and what do you guys need for this class and how are you guys going to become successful. So now, in order to get a 5 on the AP Computer Science test, our class will teach you all the necessary concepts, but at the same time, you guys are going to have to study on your own, and you're going to have to get the following. You're going to need to get a test prep book, such as Barron's.
Yeah, we recommend the Barron's.
Yeah, we definitely recommend Barron's. I don't think they have the new one.
They don't have the one out for
the current APCS test because originally, last year and the years previously, there was a case study called Grid World, and that
special topics that we're not.
Yeah, and that isn't going to be covered anymore. So now, in order to, so here's what you guys need. You guys are going to need a Barron's prep book, preferably Barron's, but yeah, a Barron's prep book. You're going to need, and with this book, later on in the year, you're going to have to take many practice tests to make sure that you understand the material. Because there's a difference between applying computer science and having test questions related to it. Then you're going to need, every day for this class, you guys are going to need a computer. Now, this computer is simply for, and make sure it's charged too at that. Now, let's say you want to write a program. Let's say we're trying to make you write any sort of program whatsoever. We want you guys to kind of apply it on your own and try to work with it, so you guys can have a good understanding of it.
So on the AP test, you won't actually ever have to use a computer. You will be writing all your code by hand. But the advantage to using a computer when you're coding is you can mess with it, like move one line or change one line, and see how it affects the program. And it helps you develop a deeper understanding of how the code is actually working behind the scenes. So just messing with it on your own on a computer and seeing what comes out is a good way of understanding your workings. That's why we recommend a computer. It's not required, but it's highly recommended.
Yeah, and
So it's fine that you don't have one today. We told you guys not to bring one, but for subsequent classes, please do try and bring a computer.
And do make sure it's charged because you're going to use it. Okay, after each class, we're going to have some homework problems. And these problems are going to be problems are going to be posted online. So at the current moment, because we're having some issues with our domain name, until that gets fixed, we're going to post everything on a Google Drive, and we're going to create a Facebook group specifically for this class. So all the information necessary will be in that Facebook group and on that specific Google folder.
So the link to the Google folder I've put up there, I use a tiny URL, but it links you to a Google Drive folder that you guys can download stuff from. And we're going to post lesson plans there, so every day we'll post a summary of what we did in class, the assignment for that day, and helpful links, so you can look at that. And
as far as homework goes, so we're going to give you various types of problems, and it's going to range in difficulty levels. So some are going to be simple conceptual problems, and some are going to be more complex type of making your own sort of code. And we highly suggest that, and we're also going to post the solutions. But we highly suggest that you guys don't look at the solutions until you do the problems on your own. Because do any of you guys have had Miss Quay? Yeah. So Miss Quay, for example, in order to optimize learning in that class, she always posted the answers online. But at the same time, she changed one answer or two to throw you off. And then she marked you down if you didn't do it. We're not going to do that. So, but we want to make sure that you guys truly understand the material, so please do it on your own. And so the solutions will be posted, and that will be the answer to a specific code, or if we're trying to do a code sample, for example, we're going to post the code that's the optimal strategy for that. So that's homework. What else? Yeah, so if you're absent, again, everything will be posted here. And for these videos, right? These videos.
Oh, he's recording us right now.
Yeah, so these videos, this is the video of the lecture, and this will be posted on the MSJ ACM YouTube channel. And if you miss anything, you can look back and discuss and understand the material.
I have a question.
Yeah.
Will the videos be titled by the topic or the date?
By the date. And inside the description, we'll have the.
Oh, also this master folder, it has, we have an Excel sheet with what topics we covered on each date, and it has pretty much the entire class, you know what we're doing on each day. That is subject to change. It's a tentative schedule, but you can look at what's out there.
Yes.
Every class, the classes are Monday and Thursday.
Monday and Thursday. On Monday, it will be here in Mr. Barker's room. And then on Thursday, it'll be in Mr. Robinson's room, which is in B18.
Oh, that's all after school, right?
Yes.
After school, 3:15 to 4:15. Yeah. So, along with, any other questions? Besides along these lines. So now the homework specifically, what will it be? So it'll be for example, it'll be an APCS like free response question. It'll be a simple conceptual problem. Or we'll try to kind of twist it, and we might occasionally have multiple choice. So again, if you do not understand any of this material, please make sure to ask us after class, or even ask questions during class. That would be really helpful. But please make sure to ask questions after class and contact us individually, and we will be glad to assist you. So here are the concepts that will be discussed in this class. So
general overview of all the topics for
yeah. So the first we're going to teach you, for the first month or two, we're going to teach you the essential programming programming, the programming essentials. So, and this is your, if for those of you who have some experience, this is your variables, your statements,
Print operators.
Loops. So this is your for loops and everything in while. And this will be covered in the first few sessions. But then we'll move on to, specifically to Java, which is Java's structure, which is object-oriented programming. And don't worry if you don't know the statement yet. We'll go over it in depth when the time comes. So this OOP covers inheritance, polymorphism.
We'll post all these topics online, and you don't need to know what it is right now. We'll obviously teach everything to you from scratch. But this is for those of you who do have some experience and who just want to get a general feel of what it's going to be like.
Yeah, and this object-oriented programming is Java's basic syntax structure.
If you do go on and code in other languages, this is actually going to be prevalent in a lot of other languages like C++, objects, Objective-C,
Python, Ruby,
yeah.
It's there.
Pretty common.
So then we're going to talk about arrays. And don't worry if you don't know this concept again. And different types of classes. And lastly, we'll mention, actually second last, we're going to have some algorithms. So these are your sorting algorithms. And these are just some strategies that are going to be on the ABCS test. All this stuff is going to be on the ABCS. Okay. And lastly, if we have time, we're going to have some lab sessions so you can prep on your own. So we can help you prep for the ABCS test, which is going to be around, I think the exact date for the ABCS test is May 7th. Mm-hmm. Yeah, May 7th is the ABCS test. Yeah, so this class is just going to give you the essential basics to the computing world. You're going to, APCS isn't, so if you guys want to learn extra, please make sure, you guys are, we will be happy to help you or assist you in learning any other information, but this class only covers the APCS information.
Absolutely essentials.
Yeah, and you guys will have to prep on your own to understand different concepts, but we're here to assist you. So remember that. So, yeah.
Okay, so I'm just gonna, we just gave you a bunch of names. I just want to go over roughly what all of this means in real world terms. So for example, an array, it's a list of a bunch of things that, so for example, you would work with a list of students, and if you would want to sort them in alphabetical order, or you could search through a list for names. These are just some of the kind of things you're going to learn to do using a programming language. Object-oriented, you're going to learn to think about programming in a real-world sense. So for example, if I have, this might sound really random right now, but when we go into it later, it'll make more sense. If I have object stapler, a function pick up, a function press, things like that. So you're going to learn to think about programming in a really real-world way, which is what object-oriented means. So yeah, we'll go into all of that later, but what we're going to do now is I'm going to walk you through how you're actually going to be coding. So you're going to need a programming environment, and the one that we're going to be using is called Eclipse. And we have, when you go to the folder tonight, you'll see links to downloading Eclipse. And we're not going to go over exactly how to download it because it's different for every operating system, and depending on whether you have a Mac or Windows, it's going to be different for you. Oh shoot, one sec. Let me just hook up to the connector, but basically, I'm just going to show you right now what Eclipse looks like, and we're going to walk through a really basic program.
Just as some quick extra information, you don't actually need Eclipse to program in Java. You can do it just using Notepad and a command line. Eclipse just helps you organize everything.
environment that you're going to be using. We'll go over exactly what buttons you'll need to use on Eclipse, but Eclipse is a way for you to type in your code. Eclipse processes it, and what we have talked about, the Java virtual machine thing, converts it to zeros and ones and tells your computer what exactly to do. So Eclipse is the programming environment you're going to use. For those of you who have used other code editors, it's like Sublime Text, Robot C,
Yeah, C++.
yeah, so, well, it's just an environment. So you're going to download it tonight, and now we'll walk through the structure of a very basic program, and we want you to try and recreate this program tonight. Yeah, so for Eclipse to work, all of the instructions are on there, but you're going to need something called the JDK, which is the Java Development Toolkit. Again, the instructions will be online when you check tonight. You just have to download Eclipse, download JDK, very straightforward instructions. Talk to us if you need help. Yeah?
Do you want us to get 6 or 7?
Just get the latest version, honestly. It doesn't really matter. We're not doing very complicated
6
things.
or 7.
Do we need to get the AP Computer Science book as well? Like
So, what we mentioned before, we'll put a link to this on Amazon, AP Barron's Guide to APCS. We'll put the ISBN and stuff online for this, but it's not required, but we would recommend that you get it. For the first couple of weeks, you won't really need it.
What about the textbook for the AP Computer?
No, you will not need that.
You won't need that. It's pretty much a textbook. It's very concise, but it covers all your information. So you don't need the textbook that they use at MSJ.
In fact, to be specific, it's not even that good. So.
But yeah, we don't use that textbook. Let me go over. Does anyone know how to start writing a Java program? Let's see if you guys can give us anything. Okay.
Import whatever you need.
Okay, we're not using any imports, so we don't need that.
New project.
Okay.
Okay, so when you go into Eclipse, so once you launch Eclipse, the first thing you'll need to do is you go into File, New Project, and you can name this whatever you want. You might want to take notes in case you want to, because you're going to have to do this again at home. So if you don't think you'll remember, I would suggest writing it down. So you would go into File, New Project, then you just name your project, and there's going to be a bunch of settings on there. Don't do anything with those settings, just hit OK. Name it whatever you want. You can name it ACM, APCS, and hit OK. And then in the left side toolbar of Eclipse, you'll see a bunch of, your project name will pop up here. And it'll say ACM. Then you right click that, and you say New Class. And then you name it, the program we're going to write is Hello World. So you name it Hello World, and you hit OK. Again, ignore all settings. There's like a bunch of options that's going to give you, don't think about it. If it gives you alert, don't use default package, ignore it. Just hit OK. Eclipse is really annoying that way, but yeah. So then it'll open up what looks like an editor for you, and it's like a text editor, and then you start typing in your actual program. Does anyone know what the first line would be?
Like public name class.
Okay, kind of close.
Kind of.
Public static void main.
Nope.
You missed one line.
Almost there.
Okay,
Sorry.
that's fine. So a lot of this is going to sound like a bunch of jargon right now, and we'll go into the exact explanations of all of this later. It's way too complicated to explain to you right now. But the first thing you write is public class. You will be writing all of your programs within classes. And all of the code you write is going to be enclosed within curly brackets. Get used to these. They're everywhere. So you put open curly brace, closed curly bracket, and then you put public, static, void, main. So what you're creating right now is called a main method, And when your class opens and your computer runs the program, this is what it's going to look for. It's going to look for main. It's going to look for public static void main, and whatever is within the curly braces here, it's going to execute. So you complete this, but I'm writing string, args, and then 2 square brackets, and you open another set of curly braces. So then this curly braces is the area between here is called a block, and everything that you write within this block within these 2 curly braces is what is considered your main method. So this is all your main method. When your program runs, it's going to jump to your main method and do whatever is written inside of here. So what we're going to be, yeah?
Can you have to write the name of the class after public class?
Right, sorry. Thank you.
Doesn't Eclipse generate that for you?
Yeah, it usually does. It'll generate this and that curly brace.
When you're writing your code on the AP test, you're not going to have
yeah, so
generated, so.
The other ACM officers and I disagree on this one point, but I feel like I have to state it, which is Eclipse does a lot of the work for you, which is good if you're trying to actually get things done really quickly, but when you're learning, that sometimes might make you skip important steps that could be vital to your understanding. So that's
about
I recommend you not use Eclipse, but they all recommend you do, and it's 4 versus 1 thing, and so I mean...
We still recommend that you know the material, so
yeah, we don't recommend
we'll discuss
using
everything. So,
but yeah, we use Eclipse because it's what the APCS class admission also uses. Any other questions? Does all of this make sense so far? The computer jumps to the main method and it executes whatever within these curly braces. So what we're going to do today is a really simple program. We're going to print the words "Hello World." So what we're going to write now is a print statement, and I'm going to call it system. This is how you write a print statement. .out. So the system is outputting .print. So you open a regular round bracket, parentheses, and you put it in double quotes because it's a bunch of text. Text is always put in double quotes. Hello world. And you close that. Now, you know that in the English language,
does the capital S matter?
yes, the capital S matters. And this is, so I forgot to mention this, my bad, but Java is case sensitive. So whatever is capital has to be capital. You can't interchange between the two. So the capital S does matter, hello world. And then, so you know how in the English language you have periods to signal the end of a sentence? The same way in a programming language, you need to signal the end of every statement. So this is considered a statement, and the period for a programming language is a semicolon.
Pat Lee Walnuts, if you're on campus still, would you please call extension 37224? Pat Lee Walnuts, 37224?
So, semicolon. And then this line is going to system output print the words hello world. And then on what is your console, which is basically the output of your program, there's a console window. Hello world is going to pop up. So that's basically what it does. And now I want to go over 2 different kinds of print statements. So what we just did was system.out.print. You can do system.out.print ln. And does anyone know what the ln does? Yeah.
It prints me one.
Exactly. So it would print all of that, and it would follow it by an enter, so a return. So the next thing you would print would be on a new line. Now, can someone tell me what the output of this would be? What would that print? Yeah.
Okay.
This entire program.
Oh, hello world, and on the same line.
Immediately one after each other. Because over here, there's no ln, so it's going to print this immediately after the hello world. That A is going to get added right over there. But now if I put the ln here, then what's going to happen? Can someone?
It prints on 2 different lines.
Exactly. So this is something to keep in mind. It's going to completely change the way your stuff looks. So that's a simple print statement, and that's how you would print something. Yeah.
If the ln is on the second one, is it still the same line?
And the first one is just normal, right?
Yeah.
So yeah, then it would put in an extra line after this statement, not after that statement. So it's really important to always think about what exact decisions the computer is making as this kind of stuff happens. So wherever the ln is, it needs to place after that line. Any other questions? Okay, anything you guys, any questions you want me to answer about the way all of this is set up?
Arthur, can you just explain what a class is, kind of like what it means in like normal terms, because they might not understand that.
Do you want to go ahead and do that?
For now, all you guys need to know is that a class is just something that wraps your code.
Yeah,
Yeah, it's a blueprint.
it's
Something that wraps your code. That's all you need to know for now.
yeah, it's just kind of like I would just think of it as a reward doc, honestly. That's all you need to know right now. It's just what you put. Also, I want to talk about something that is considered good style. So it's not just enough for your programs to do what they do, and like if you call your program do my thing and you try and apply for a job, you're not going to get a job as a programmer if nobody else can understand your code. Because when you go out into the real world, you're not going to be the only one working on your code forever and ever for the 100 years that the company is using that code. There's going to be people who come after you, people who maintain it, people who edit it, people who change it, and they have to be able to understand what you wrote. So if you write a bunch of code and then nobody can understand, your code is kind of pointless. So a very common programming practice for good style is indentation. So if you notice over here, when I wrote out the program, this was lined up over here. Then I tabbed one in, and this all lined up over here. Then I tabbed one more in, and I lined this up here. And can anyone tell me what exact symbols indicated where my indents are, if that makes sense? Yeah.
Curly braces?
Exactly. So this first pair of curly braces is one indent. The second pair of curly braces is another indent. And if you see the blocks, each separate block is indented further inwards. So that it kind of, when you look at a large bunch of code, I wish I could connect my computer to the projector now to show you something really big, but the indentation really makes a difference. And when you're looking at a large program, it'll change the way that you perceive how the code is put together. So that indentation is really important. And every time you enter a new block of code, you would indent it. So get used to tabs. That's really important. So
On the same topic of maintaining code, it's really, do you want to go over comments?
yeah, I was going. Okay.
Yeah, so sometimes you can have a block of code that's really hard to read or it's trying to fill a purpose
Honestly,
that's
not even if it's hard to read, just all the time.
really like convoluted. You can comment out your code, which basically talk about comments, right?
Okay, yeah. So basically, what comments are is you can insert comments into your code, and the comments are completely ignored by the computer. We'll teach you how exactly to start a comment, but when you start a comment and the computer sees that indicator of, okay, this is a comment, it skips over it and goes to the next bunch of code. So the comment is only there for humans. So like I said before, other people are going to be maintaining your code, other people are going to be editing it, other people are going to be reading it, and you have to be able to make it so that it's presentable to humans. So now I know that this is really basic and pretty much everyone is going to know what the code is doing. But here I would, for example, okay, let me show you how you create a comment. So there's multiple ways you can write a comment. For example, if I have some print statement here, just imagine that so this is some random print statement, right? I could add a comment at the end of this line explaining what this specific print statement does. And in Java, how you do that is you put in
It goes forward.
forwards, right?
Yeah.
I can't remember. Okay.
/ goes forward.
Yeah, it's this.
It's this one right there. You put 2 forward slashes, not backslash, forward slash. 2 forward slashes, and you write whatever your comment is over here. And when your computer comes to these 2 forward slashes, it's going to completely ignore that. So that is only there for the programmer's understanding. And what you would typically write here for this kind of a statement is printing A. Now obviously this is a really simple statement. You're probably never going to comment a print statement and tell the person what you're printing. But like when you're doing more complicated things and you're making calculations and you're doing a bunch of stuff, then it's really important to explain what your thought process was at the time. So this is what is called a single line comment. So the 2 forward slashes. This is one kind of commenting. Now the second kind of commenting is a multi-line comment. And this is typically seen when you initially create a class. So at the very top of your class, any questions? Okay. So at the very top of your class, you would have what is called a multi-line comment, which would maybe explain the purpose of your class. This is a class that aims to create a register and carry out functions on all the money within it. Or aims to carry out financial transactions, something like that. Or this is a class that adds 2 numbers together. So how multi-line comment works is it starts with 1 forward slash, then there's a star, then you write whatever, and then once you're done writing how much ever you want, you put another forward slash and you put a star.
No,
Star before. Sorry. Okay. So the stars are inside and the forward brackets are out. Forward slashes are outside. And whatever you write within here, again, the computer would ignore.
Let me add something. So you might be wondering in what real-world scenario would, like, you forget to comment something, how much harm could it possibly do? Here's a good example. Have you ever noticed in Windows 7, there's no more pinball? You can't play pinball anymore in Windows 7? Yeah, that was caused because back in XP, when Windows had a copy of that pinball game, when they were changing XP into 7, there was some technical jargon, and they had to change the way that the pinball worked, sort of. And when they read the code, it was thousands of lines of codes, 0 comments. They had this error where in the Windows 7 version of pinball, the ball would fall through the flipper, and they were trying to figure out how to fix that. But since there was no comments, they couldn't even figure out which part was the flipper part. Like what part of the code had anything to do with the flipper. And so then they ended up scrapping it, which is why we can't play pinball anymore. Because some person forgot to put comments.
So comment your code, basically. TY, for example, and
Yeah.
So yeah. Game engines to make games, and it's a lot more organized.
Yeah, but this was an XP. Well, back then, game engines
there
were
still
kind of
usually is
crappy.
some amount of code. Almost always.
Did you read that on Hacker What was that?
So this is a multi-line comment. And now, is Javadoc in the APCS curriculum? No, right? Is Javadoc? Okay, so I'm going to talk about something that isn't, I don't think they ask it in APCS. I'm pretty sure that they don't. But it's something that's very useful when you're using Java. So it's called Javadoc comments. And basically what Javadoc comments are is when you're writing code that, for example, that someone else is going to use and you have a class. And you've defined a bunch of methods. So for example, eventually we'll be using the math class, which has some methods like add, subtract. Okay, nobody uses the add and subtract, but it has stuff like power, it has stuff like square root, it has log, it has ln, things like that. So within that math class, you have a bunch of methods. So what Javadoc does is it's a specific way of commenting classes that you create so that this inbuilt thing in Java called Javadoc creates basically kind of a manual for your class. And anyone who wants to use that class kind of knows what each method is trying to do and what variables each method uses, stuff like that. It might sound kind of complicated now because we haven't explained a lot of these terms, but Javadoc is basically, if you want a certain comment to be included in this manual that Java would create for you, you would put Javadoc comments, which is really simple. You just add an extra star to your multi-line comment, and then it gets added to that manual thingy, and those are how you do Javadoc comments. We won't really be doing much of it in this class because it's not part of the APCS curriculum, but it's something that's kind of handy to know. I took Intro CS at Ohlone, and it was required over there that you Javadoc commented all of your programs. You probably won't require it, but just something cool to know. So again, to go over everything that we discussed today, we talked about how you go into Eclipse, you create a new project, then you create a new class, and within that class, you write public class, open and close curly braces, and please be careful of making sure that for every open curly brace you have a closed one. Eclipse is really good about adding it for you, so make sure that you don't add an extra one. Because on pretty much every new version of Eclipse, I'm sure, when you add an open curly brace, it automatically adds a closed one for you. But curly braces can literally break a program. Because I've written code, okay, I'm going to admit it was badly designed code, but there were 17 sets of open closed curly braces, and if you miss one anywhere, boom, it doesn't work. I mean, it says that it throws an instant error at you. It doesn't even run and do something wrong, it just won't even run. So just be really careful about your curly braces.
But you guys don't have to worry too much about it because it tells you when to do it.
Yeah, so Eclipse is pretty good about that, but when there's a lot, it can get really confusing to figure out where you left it out. So, curly braces. So public class, open close curly brace, then your main method. So, okay, I don't have it. Public static void main. Open close parentheses, string, capital S, args, 2 square brackets. I know it's a bunch of really random words right now. We'll explain these words as we go on. But basically, what public is, it's saying that any other classes can view my class. I know that, okay, that's probably really obscure right now, but it's basically everybody can view it. You can have public and you can have private. It's, okay, whatever, let's not go into that. It's not complicated. Public static void main. And if you notice, there's an indent here. And then after public static void main, open close curly brace, indent again, system.out.print. You don't really need the ln because, or whatever, with the ln. Okay, system.out.print ln, hello world, semicolon. It's your period. Don't forget the semicolon. They don't take points off for this on APCS, by the way, because it's something that a lot of people forget a lot of the time. They don't take points off if you forget your semicolons. System.out.print, a semicolon again. And always remember, if you wanted to print text, you put them in double quotes. And then the 2 closed braces, which you should have already put in when you created the open braces. So,
Are there any questions?
yeah. Okay.
Comments make the code slower.
No.
No, the computer doesn't even read it, it doesn't
Yeah.
care.
Remember how I said Java composite into an executable code that goes into the JVM? When that JVM converts it into machine code, the comments aren't considered. So when the machine that you're running the code on is actually executing what you wrote, it's going to be running zeros and ones. And those zeros and ones,
We don't even look at comments.
yeah.
And honestly, within the scope of this class, pretty much everything you write is going to run like in probably less than a minute. It takes like no time. We're not writing complex stuff at all. If you do like a crazy amount of math calculations and try and compute a bunch of Fibonacci numbers, yeah, it might take a while, but don't do that. Because if you do it wrong, you're kind of going to kill your computer. But the stuff you're doing in this class should not take too long to run, because if it is, you've probably done something wrong. So yeah, just keep that in mind. You don't need to worry about speed at this point. And comments over speed. Comments, speed. Always comment. Or no pinball. Who knows?
Are there any other questions?
Yeah.
Could the A also be in single quotes because it's like
Yeah, I can.
Yes, it can. Good question. Anything else?
Any questions about the compiler? Because it's a very important concept.
Yeah.
How this human readable stuff turns into this binary. We don't have any questions.
Well, the APCS test does not test you on the specifics of how all of that is converted. I've actually never seen it on a test, but it's good to know.
Good to know, or else you might. Yeah.
Is the test just like they give you something, a problem that you're writing program to fix it, or is it?
That's the essay one.
So the test has a bunch of different kind of problems. For the multiple choice, one of the common question types is they will give you a bunch of code, and they will ask you what the code does. So they'll ask you, we'll deal with variables next class, but they might ask you what's the value of this variable once this code is done running. Or they might ask you if this code stops at a certain point of time, what would the current state of the program be? Stuff like that. Or they could be recursion problems, which we'll explain later. It could also be
In simple statements, it could be something about something conceptually. So it doesn't necessarily have to be about specifically about code. It could be something about a concept at that too. There's many different ways that they ask questions.
So in theory, I guess they could ask about this whole thing about the Java virtual machine, although I've never seen it.
Yeah, they barely ever ask that kind of stuff. Then we can bring a couple of practice questions in. Occasionally, they might ask you if this code was changed and this line was added, what would the change be in the program? And then, so that's the multiple choice. In the free response function, you just write programs. They give you a prompt and you have to write a program. There's 4, right? Yeah, there was 4. And usually the trend on the APCS test, so far at least, has been they're changing it slightly this year. But so far, the multiple choice is more of the time crunch part. Free response, I know people who've taken naps after they're done. So free response is like really relaxed. Any other questions?
So in the public class and all of that stuff that you wrote on that side, do spaces matter?
Yeah. Okay, so now if you forgot this space, yeah, that would matter because then you're not separating 2 words. But like if after say this parentheses in between that we forgot a bunch of space, that doesn't matter. And this indenting is completely ignored by the computer. The indenting doesn't matter either. It's mainly just when you separate words. Now, for example, in system.out.println, the spaces, if you put a space in there, it won't run. Yeah, it will not. Same thing, but if you put a space before a semicolon, it should run, right? It doesn't. Yeah, it will. So it's kind of subjective. I honestly don't have any rules to it. You kind of just get used to where it matters and where it doesn't. After a point of time, it starts becoming a little bit of intuition kind of thing.
The thing with spacing is that there's actually a book about this thick about the styles of Java, and it states pretty much every single rule you're supposed to abide by, telling you where you can put spaces and where you can't.
And that's like convention.
It's convention, just so that like if I read your code, it makes sense to me. I can read it, I can find what I'm looking for.
But at this level, I honestly can't see where putting an extra space is putting 2 spaces instead of 1 is like going to end the world. So you're fine. Yeah.
So you could cram all that code into 1 line.
Yes, you could. Yes,
Oh yeah, yeah.
Yeah, but people will hate you for it. I mean, like they won't be happy. Your future boss and your programming won't be happy. They'll look at that and they'll go, I can't read this.
This is fine.
Well, yeah, but if you cram it all into 1 line, it's still kind of annoying to read.
Wait, what?
No, he's saying if you crammed it all into 1 line,
Oh.
1 line.
Oh God. Wait, is that what
Yeah.
you're implying?
You
No,
can do that.
Don't do that.
You can. In theory, you can. But the computer can read it. The computer doesn't care that much about like how ugly your organization
You
skills are.
probably if something happens, you probably won't be able to find where you made the mistake. It's just like one gigantic line. Don't do that.
Well, actually, you kind of can, but it's just
Well, if you want to try out the AP test, tell me what you get.
Oh wow, yeah, that would be interesting.
That would be really funny, actually.
Yeah, any more?
Like, you know that meme where they go, I'm not even mad, that's amazing? That's probably what your grader will think if you manage to do that. Do it correctly.
At some point in time, pretty sure that new lines do matter in some places.
Some places not.
Yeah, you wouldn't be able to write absolutely everything on 1 line. That's crazy. Yeah. Any questions? What's your name?
Are we good then?
Anything.
Alright,
You
so
can let them take like.
I
Yeah.
didn't get the URL.
Oh yeah. Okay.
So we're gonna post everything online.
We'll send out an email, but the tiny URL is kind of like. Wait, what?
Actually, no, we'll post it. You don't.
Resources.
So by Thursday, please have the clips downloaded and ready. All the instructions will be given to you guys.
Yeah.
And try to replicate what we did today in class.
Yeah. So write a hello.
Writing.
Yeah. So if you guys take this down now and you go into that folder, it'll have all of the information you need. For every class session, we'll create a new document which will have what we covered that class, and it'll have the assignment. So go into today's document and look at the assignment. There's the links to download Eclipse, and then there is a link to the Hello World code if you do want to look at it, but I would recommend that you try and replicate it from memory.
If any of your friends couldn't come to the lecture, this video will be posted online as well, along with all the notes that were taken.
And if you will, tell them to make
What's
it.
the point of using REs?
Oh,
It's just for when you want to input things into your program, but for the computer science test, you have to worry about it.
Yeah, just always put it. Wait, that isn't even on. Yeah, you never get a question where you have to do that.
but in
Will it run with logic?
no, but
It's not going to.
It's not gonna. Okay, for purposes of computer, AP computer science, just do this. It makes
It's
life
actually,
easy and
I realized it doesn't even show up on the test because the kind of programs that make you run on the test right after is pretty strange. We'll never have to do that on the test, but we're going to do it in this class for assignments.
In the future, when you run larger and larger programs, some of your programs will not contain this.
Yeah,
But some of your classes will.
they won't even contain that entire line. Just calm down, guys. You're going too far ahead. We have a while. Yeah.
Basically, the main just tells the computer